All right, moving on with your twin. A pesticide kills. That would definitely be decay, wouldn't it? Kills, decay. All right, so the amount after time is going to be some principal times 1 minus r to the t. That's your form. Now, let's see here. We got 15%. Last I checked, that's 0.15. Remember, you shift that decimal 2 places. And 1 minus 0.15 is going to be 0.85. I don't know what the principal is, and I honestly don't care. I really don't. You put a 1 there or something. 100% of bugs. Who cares? The exponent's going to be t over what? 12? Determine the hourly kill rate. All right. So if I want to make this an hour, time would be 60, right? 60 minutes equals 1 hour. So what we're going to do is we're just going to replace that t with 60. And let's see what happens. You got 0.85 rooftop to the 60 over 12, which is 5. But, you know, if you don't know that, TI-84 don't judge you. And you get this decimal, 0.4437. Now, we need to understand this, and this is the hard part for some kids. This was the amount after 60 minutes that was left. That's what that was. This is saying that there are 44.37% of the bugs left, which means you take 100, subtract that from 100%, and we've got 53.63% remaining. That's not right, not 53. Ugh, bad. 55.63% remaining. So, you know, I can tell you right now that a lot of kids, I'll make this multiple choice, a lot of kids will pick the 44.37. But the thing is your formula is the amount after time left. And I just said that there was 100% of all bugs. That's why I let the P be that. Maybe I should have put 100 here. Maybe that would have made more sense. Put 100 there. Because you have 100% of all bugs. And if I'd have done that, that would have said you would have had 44.37% remaining. I don't know. But again, that is remaining bugs. So you got to take that away from 100% to figure out what you actually killed. And that should be the word killed. I'm off to a great start this morning, aren't I? All right. All right, given f of x is the square root of 6x minus 4 and g of x is 2x plus 2, find f of g of 4. Oh, I hope this goes better than it has been. I really do. Of course, I put this in some homework, and some people asked about it, and a lot didn't. But if you don't know how to find f of g of 4, I would say you're probably going to fail my course. You let x be 4 in g first, and then you go to f. Plug the result into f. So let's find g of 4. It's twice a 4 added 2. That's 10. 2 times 4 is 8. Plus 2 is 10. So now we're going to find f of 10, which is the square root of 6 times 10 minus 4. And that's the square root of 56. And it does say be sure to simplify radical. And radical simplification is not an algebra 2 skill. It's an algebra 1 skill. You know, when you think about 56, and I know the issue is you thought it was stupid to have to learn your multiplication tables. Joke's on you, dum-dum. Anyways, 56 is 4 times 14. So I'm thinking about this root of 56 as the root of 4 times the root of 14. And the root of 4 is 2. So this just reduces down to 2 root 14. Oops. All right, 13. Given f of x is x squared plus 3x and g of x is 2x plus 4, find f of g of x. It's very similar to the last one. but you're not plugging in numbers. You're going to use substitution property. You put that 2x there. You're actually finding f of 2x plus 4, which means that every x in f becomes 2x plus 4. I can't make that any clearer. I can't. That's what it is. Verbatim, this is what you do. So let's start writing that thing. F of 2x plus 4. I see an x, it becomes 2x plus 4. I have to square that. Plus 3, there's an x, it becomes 2x plus 4. And if you think that 2x plus 4 squared is 4x squared plus 16, you failed. Like, you don't have it. I have said hundreds of times that if you're going to square something, you're going to write it twice. That's on you. Like, you need to get your head in the game. Distributive property, 6x plus 12, which I've got kids, juniors this year, still can't do the distributive property. Why are you wasting time here? Like, why? 2x times 2x, 4x squared. 2x times 4 is going to make an 8x. Another 4 times 2x is an 8x. You put those together, you got 16 of those x's. And then 4 times 4 is plus 16. And we just need to combine all our like terms. It's not a hard thing to do. It looks to me like there's 22 x's. Oh, 16 and 6, yeah, 22x. And then we got a 16 and a 12, which is 28. Easy peasy lemon squeezy. All right. Be right back. All right, so moving on to 14. On 14, you're going to use your calculator to find the real zeros, and then you're going to use synthetic division to factor the equation down to a quadratic, which you can hit it with a QF, quadratic formula, if you don't know what I'm talking about. So I've already gone to y equals, and I've already done a Zoom 6. I'll do it again anyways, just to prove to you that I did a Zoom 6. And this one's going to be harder than the one on the test because it's a twin, and a twin should be a little harder, because if you can do something hard, you can do something easier. So this 0 is not a nice one. Like, it's somewhere between 1 and 2, right? You probably 1.5. But if I want to know what it is, I just need to put a 0 in y2 because I'm trying to find the zeros of the function. And then I'll be able to use second trace 5. And once you have an intersection, you just get close to old intersection and you press enter 3 times. There's my cursor. Enter, enter, enter. And the intersection's at 1.5. And that's the number that I'm going to synthetically divide out. And we'll just leave it as a decimal. Whatever. Half of y'all wouldn't understand that that's 3/2. That's kind of sad. So coefficients for synthetic division, 6, -9, 54. I don't know why I wrote the plus sign. And then minus 81. And your acronym here was DMA. Drop and then multiply and add forever. So you drop the 6, and sure enough, 1.5 times 6 is 9. -9 plus 9 is 0. 0 times anything is 0. 54 plus 0 is 54. And half of 54 is 27. So you got 1 times 54, which is 54. The half, which is 27. You put them together, you get 81. And you add and you get a 0. Now, I actually get to stop on this one here because this is a quadratic. This is the remainder, the constant, the x, and the x squared. So I am left with 6x squared plus 54. And I'm supposed to find all the zeros. So I'm going to set this thing equal to a 0. And 2 of these zeros are not real. These are not real zeros. Big whoop. It said find all. So what I'm going to do is I'm going to subtract 54, divide by 6. Those are both 54 will enter 6 -9 times. Or 6 will enter -54. And then I'm going to take square roots. Now you do need to remember that the square root of a -1 is I. So that's part of this. So x is plus or minus the root of an imaginary root of 9. So x is plus or minus 3i. All right, number 2, express your zeros using function notation. Okay, so this was the first one. F of 1.5 is a 0. That's how I read that. F of 1.5 is a 0. One of your zeros was 3i. So f of 3i is a 0. And lastly, f of negative 3i, guess what it is? It is a 0. You see how I'm reading that? F of, I should actually say f composed of 1.5, but you know, that's what I'm saying. I'm saying f of 1.5 is a 0. That's all there is to it, kids. If these were factors, we would have flipped the signs, but they're not. They were the actual legit zeros. All right, 15, we got a graphing problem. By hand, graph this thing. Please show the shift, state the domain, state the horizontal asymptote. You're gonna have a table too. There'll be a table for you on your test. I promise you there will be. And let's change that from please to show the shifts. I don't want to give you an option. Show the shifts. So this guy right here to me is a right 3, and I hope it is to you as well. And I'm going to show that shift because that's going to help me make my table. On my table, that's the centering value. Up 2 is an up 2. And that's kind of a big deal because what is that thing? And by the way, that is where y is 2. That is the horizontal asymptote. That is the line you cannot, shall not, will not pass. Now, let's go back to the table, plug some numbers in. Something above 3 is 2, something after 3 is 4. And then we're just going to plug stuff in. So if we plug a 2 in, this becomes negative 1. This is 2 times 3 to the negative first plus 2. The 3 to the negative first is brought to you by this property. So that becomes 1 over 3 to the positive first. So what we have here is we have 2 times a third plus a 2. And 2 times a third is 2/3, and 2/3 plus 2 is 2 2/3, which has a decimal, 2.67. I know you don't believe me. You can push buttons on a calculator, and you'll find out that I'm 100% right on this. If you plug in a 3, you're going to have 2 times 3 to the nothing plus 2. And not everybody has this down yet, but anything to the nothing is 1. 2 times 1 is 2, and then add 2 and you get 4. If you plug in a 4, you'll have 2 times 3 to the first. And I know full well that there's probably 15% of my juniors who have no idea what 3 to the first is. And don't date that kid. Don't. I would suggest bullying, but that's not cool. Tempting. I'm just kidding, by the way. 2 times 3 is 6. 6 plus 2 is 8. But, maybe you should find that kid and help that kid, but do not date that kid. Don't do it. Anyway, there's your points. We got 2 and then 2.67. We got 3 and 4. And then we got 4 and 8. 5, 6, 7, 8. Of course, you'll have a grid you can use. Remember, you flatline near the asymptote, and then this is a growth function. And it looks a little something like that. All right, solve 3 to the 2x minus 1 equals 1/27. I wish I had a set of parentheses around that. I didn't put one in there. So the property here is if some x has an exponent of a, and it's equal to some x with an exponent of b, then a is b. So your task here is to get the bases to be the same number. Now, this was taught to you on Friday. You didn't have homework on it. So, who knows if you remember it or not. So what I'm going to do is I'm going to look at 1/27th, and I view that as 1 over 3 cubed, which means that using a property like this, I can make it 3 to the negative third power. So I'm going to leave the left-hand side alone. The right-hand side is going to become 3 to the negative first, and I already had in the exponential space 3x plus 4. And now that the bases are both 3's, I can just chunk them out the window. I don't need them anymore. So 2x minus 1 equals, let's use the distributive property, negative 3x minus 4. And then we're just going to add 3x to both sides. And that's the thing about Algebra 2, which is what kills me. In Algebra 2, I should not be teaching two-step equations every single day. A kid should look at that and know what to do. Why don't you know what to do? I don't get it. But I put my x's over here, so my numbers are going over here. Negative 4 plus 1 is negative 3. Divide by 5 and you get -3/5. Easy peasy lemon squeezy. I had to put on 17 that it's not a multiple choice question because on the last twin that I did, kids didn't watch the video and they just picked an answer. They picked either A, B, C, D, or E. It's not a multiple choice question. It's a question that's got 5 pieces to it. But somebody can still do it this time. So first off, you're supposed to find f of 2. And what that means is you find y when x equals 2. It ain't hard. Let's say this like you might comprehend it. You find y when x equals 2. I hope that helped. So anyways, it's about f. When x is 2, I would be right here. You can see my cursor. And I'm going to look up at the function. I'm going to look over at the y-axis, and by golly gee, wow, it's 3. When I do example B, I like to go old school. Maybe that's because I am old school, apparently. So what I'm going to do on this one is I'm going to find y when x equals 2 on G, and I'll plug the result into F. So G of 2, I go to where x is 2. But this time I look at function G. So here's where x is 2. I look at G, and it returns -4. See that? Look at the y-axis. So this becomes f of -4. So now I go to where x is -4, and I look at function f, and it returns, it looks to me like a 5. Looks like 5 to me. It's not rocket science, kid. It's not that hard. C is f of 4. Old school would be f parentheses 4, close, close. So we're going to start on function f. We're going to go to where x is 4. We're going to look at y. We're going to get -1. So this now becomes find f of -1. So I go to where x is -1. I look up at function f, and I check the y-axis, and I can count to 4, and that's the result. G is GOG of 5. That's how some kids say it, but G composed of 5. So I go to where x is 5. I look at function G, and I get a -1. So it becomes find a G of -1. And now I go to where x is -1, and since it's still talking about G, I glance down at G, and I see that she is in fact -5. And finally, f of G of 1. F composed of G composed of 1. G of 1 is -5. So this becomes find f of -5. So when x is -5, you'll see that there's nothing here. D, N, E, just like this twin, right? Pretty sure that was it, and it was. So yeah, let's redo this pen drop. Enjoy, kids. Good luck on your test. I mean that. It'll make my day a lot better if you do well. So just think about me. Don't be selfish. Study, do well.